Hi guys, welcome to Matsi. With me, Miss Resi, your teacher for today. Now let's find the equation of the ellipse given these conditions. For the first condition, find the equation of the ellipse whose vertices are given at negative 5, 0, 5, and 0. Foci at negative 3, 0, and positive 3, 0. The center of this ellipse is the midpoint of the vertices, which is the origin. Each vertex is 5 units from the center, thus A is equal to 5. Similarly, each focus is 3 units from the center, thus C is equal to 3. The value of B is obtained using the Pythagorean theorem, or this one. Substituting these values, we have the axis of the ellipse is horizontal. For horizontal, we need this formula. Substituting these values, we have so this is the equation in this given condition. So let's try this. The endpoints of the major axis of the ellipse are 2, 2 and 2, negative 10, and the length of the latest rectum is 16 over 3. Divided by 3 is 5.33. And the midpoint of the endpoints of the major axis gives its center, which is 2, negative 4. So where is 2, negative 4? So if you will count the units from the two endpoints, it will have 12 as their distance. So 12 divided by 2 is the midpoint. So we have 6. 1, 2, 3, 4, 5, 6. So this is positive 2, negative 4, midpoint. Thus A is equal to 6. The latest rectum is 16 over 3, or 5.33. Therefore, our formula here, 2b squared over a. So the latest rectum is just 16 over 3. So if you're going to imagine, b squared here is equivalent to 16. So we obtain the value of b squared, which is 16. If this is vertical orientation, the formula we're going to use is this. So if this is not from the origin, it is an example of the shifted ellipse. Let's use this formula. From the midpoint to -4, we now have the value of h, comma, k. Therefore, the equation for this condition is this. Lastly, find the equation of the ellipse with foci at -3 minus square root of 3, comma 5, and -3 plus square root of 3, comma 5. And with a length of latus rectum equal to 1. So our y is equal to 5. 1, 2, 3, 4, 5. The ellipse here is oriented horizontally. The center of the ellipse is the midpoint of the foci, which is -3 and 5. So what is the midpoint here? So c is equal to square root of 3. So that's the midpoint. So using this equation, the length of the latus rectum, we use 2b squared over a is equal to 1. Equating this formula, we have b squared is equal to a over 2. To solve for the value of a, let's use this. So let's multiply the whole equation by 2 over 1. Solving this equation, we get this one. So let's solve both sides. Equate to 0. So our a is -3/2 and +2. Since the value of a represents a distance, we consider the positive value, which is a is equal to 2. And because we have the value of a and c, let's solve for b squared. Horizontal formula. From the given, the value of h and k here is substitute the values we have. Or let's simplify that. And that is the equation for this given condition.